Alright, so today's lesson is actually not going to be involving proofs. I just want to review a little bit of factoring with you guys. So if you still have your Algebra 2 ISN, I highly suggest you dig that thing out and you might rip out this toolbox, factoring toolbox that we did. It was on page 69 of your old ISN because we're going to be using all of these factoring methods at some point in our proofs. We're going to be using some more than others, but it might just be nice to have that available. If you don't have one though, we are going to do a couple little examples, but it's not going to be as thorough as all of our steps in our toolbox from last year. So one of the first things I want to show you is factoring using a GCF. A GCF just stands for your greatest common factor. So basically, whenever you have a string of terms all added and subtracted together, you look for what's in common and you're going to factor out a GCF. So for example, say you have sine squared x plus sine x cosine x plus sine x. Well, you can see there's a bunch of signs there, and these addition symbols are separating each of these three terms. Term 1, term 2, term 3. And they all have a sign portion. This actually has two signs, but since they all have one, we can factor that out, and that means pull it out front. And then in parentheses, you're going to write what's left behind. We're basically undistributing. That's another way of saying factor, undistribute. So what's left behind is going to be a sine x plus cosine x plus 1. And you can see all those signs got pulled out front. And this might be useful to you if, say, this was all over a denominator of sign, and then you could cancel, or something like that. Another method of factoring is where your trinomial has an a equal to 1. So what that means is whenever you would have a function like, say, x squared minus 3x plus 2. We used to be able to factor that by setting up two sets of parentheses, looking at this last term and its factors, which were 1 and 2, or negative 1 and negative 2, and then figure out which ones add up to b. We would say factors of c that add up to b, and those would be the ones that we would put in our parentheses, and then x here, and we just factored that. And if you FOILed it back out, you would get back to this answer. Whenever I say a equals 1, I'm just referring to the number in front of your x squared, if you didn't have me last year. So that's how you would factor with x's. But it's very possible to have something like this in trig functions. For example, say we were to have sine squared x plus 2 sine x cosine x plus cosine squared x. Okay, that looks like a big ugly mess. And if you didn't know to look for this, it would really cause you some problems while trying to do a proof. But what I see here is that we have something that can be factored. If I write this as sine x plus cosine x times sine x plus cosine x, I could FOIL this out and it would get back to this same answer. So I just wanted you to have that one in your notes so you can kind of know that one, because that one comes up quite a bit. But you could also have something that fits more like the format that I just showed you, like sine squared x minus 2 sine x plus 1. Okay, so you might have something like that. And if you look at this closely enough and kind of think in your mind to substitute in an x for sine, then it kind of looks like this. X squared minus 2x plus 1. So we can factor it very similar to the method that I showed you above. We're going to look at factors of 1 that add up to -2. And then we're going to put those in our parentheses. So -1, -1. And then instead of an x going here, we're going to put sign. So those are some ways that you can factor trig functions if your trinomial is where a equals 1. Another thing that comes up a lot is adopts. Dops that we learned last year is a difference of perfect squares. And an example of this would be x squared minus 9. You can see that it's a difference because there's subtraction. And then it's a difference of perfect squares because x squared is a perfect square and 9 is a perfect square. So anytime you see something like this, it can be factored. Some trig examples include, I didn't write examples on any of these. Here we go. So an example of this in trig might include sine squared x minus 1. So notice there's a difference in the middle, and these are both perfect squares. Sine squared x and 1 are perfect squares, so we can rewrite that as +1 minus 1, and then sine x, sine x. And that's how we would have factored this above. You just take the square root of your first term, they go here, 1 plus, 1 minus, take the square root of 9, that's 3 and 3. So we do the same process here. Another example might be 4 minus cosine squared x. So you can see again, there's subtraction in between them, has to be subtraction in between, and then you've got a perfect square and a perfect square. So in your parentheses, you would do the square root of 4, that's 2, put it here and here, put 1 plus, 1 minus, and then the square root of cosine squared, that's cosine x. So this can be helpful sometimes whenever you're trying to cancel a weird quantity that you just can't get rid of. Maybe you can use some of these. And there's more methods of factoring, but these are the main ones that I've seen in my experience. So these are the ones I wanted to show you in the video. I would like for you guys to pull out that toolbox though, just in case any of the others pop up. That way you have some notes. Now we're going to do some example problems.